Welcome to the next episode of the Dark Web Deacon. Before we begin, be sure to smash that subscribe button, click the bell to turn on notifications, and check out the latest items in the Dark Web Deacon merch store. There is a link in the video description below, and become a true Dark Web enthusiast. New videos are published every Monday and Thursday. MIT researchers have discovered a magic material for versatile electronic devices that may produce new insights into quantum computing by 1. Making them easier to manufacture, and 2. Providing components that are more error resistant. If you're brand new to the world of quantum computing, I would check out my previous video, What is Quantum Computing? Simply Explained. MIT researchers and colleagues have turned a material composed of atomically thin layers of carbon into 3 useful electronic devices. Normally such devices, all key to the quantum electronics industry, are created using a variety of materials that require multiple and expensive fabrication steps. The MIT approach automatically solves a variety of problems associated with this more complicated process. As a result, the work could usher in a new generation of quantum electronic devices for applications including quantum computing. The new magic material is based on graphene, a single layer of carbon atoms arranged in hexagons, resembling a honeycomb structure. Since the first isolation of graphene in 2004, interest in this material has skyrocketed due to its unique properties. For example, it is stronger than diamond, transparent, and flexible. It also easily conducts both heat and electricity. In 2018, the Jariyo-Harada group made a startling discovery involving 2 layers of graphene, one placed nearly on top of the other. One of them was actually rotated at a magic angle of 1.1 degrees. The resulting structure allowed the graphene to be either a superconductor, which means conduct electricity without resistance, or an insulator, which prevents the flow of electricity, depending on the number of electrons in the systems as provided by an electric field when various voltages were applied. The overall magic material, formerly known as magic angle twisted bilayer graphene, aka MATBG, has generated intense interest in the research community, even inspiring a new field known as twistronics. A material that can both be a superconductor and an insulator at the same time, depending on various parameter changes, is what makes it so magical. Suddenly, the team was able to tune different sections of the same magic material into a plethora of electronic states, from superconducting to insulating to somewhere in between. Then, by applying gates in different configurations, they were able to reproduce all of the parts of an electronic circuit that would ordinarily be created with completely different materials. Ultimately, the team used this approach to create 3 different working quantum electronic devices. These devices included a Joseph-Sun junction. Why is that important? Well, Joseph-Sun junctions are the building blocks of quantum bits, aka qubits, behind superconducting quantum computers. The team also created 2 related devices, a spectroscopic tunneling device and a single electron transistor, or a very sensitive device for controlling the movement of electricity, literally 1 electron at a time. The former is key to studying superconductivity, while the latter has a variety of applications, in part because of its extreme sensitivity to electric fields. This work paves the way for many potential future advances. It could be used to create the first voltage-tunable qubit from a single piece of material, which could be applied in future quantum computers. Researchers are hopeful that it could also allow insights into the creation of high-temperature superconductors. Current superconductors can only operate at very low temperatures, which is one of the biggest obstacles in order to allow for the widespread adoption of quantum computers. At a 2021 summit, Google unveiled its ambitious quantum computing project leveraging some of this magic material, which it claims to be useful and error-free. The error-corrected quantum computer it says will be ready by 2029.
Thanks for watching, and as always, please like, subscribe, and provide comments, and turn on notifications by clicking the bell in order to check out future videos published twice a week.